Hello everyone, I'm your tutor today. I'd like to preface that if I make a mistake or if there is another way to solve the problem, please leave a comment. If you have a question or I didn't explain anything well enough, then also leave a comment for that. So our question today is, one afternoon, a couple walks 3/4 of the way around a circular lake, the radius of which is 1.63 kilometers. They start at the west side of the lake and head due south to begin with. What is the distance they travel? What is the magnitude of their displacement? And what is the direction of their displacement? So we have a couple questions here. First one we're going to start with is A. So we'll go ahead and go with A right here. And let's start with everything that we know. So I'll go ahead and draw this. We'll see what they have. We have a circular lake. So we have a circle right here. We know they walk 3/4 around it. The radius is 1.63 kilometers. 1.63 kilometers, and we know that they start at the west side of the lake and head due south. So they will start west side right here, and they will head south. Since they walk 3/4 of the way, we know that they will travel this direction and end up north. That is 3/4 of the circle. So we'll go ahead and start with A. What is the distance they travel? Well, we know that the radius is equal to 1.63 kilometers, and we can use that with an equation. We can use 2 pi times the radius to give us the circumference, which would be the entire thing here. Now, we're going to need that because then we'll multiply it by 3/4 later to get the exact distance they have. So first we'll multiply it with this, so we'll do 2 pi times 1.63 kilometers. We'll put that in on our calculator. And we get 10.24 kilometers. This is equal to 10.24 kilometers. So this is the total distance around the lake, but we only want to know when they walk from west around and end at the north part of the lake. So we're going to multiply this by 3/4. And we end up with 7.68 kilometers. And this is the total distance that they walk, starting from west and ending at the north spot. So now we'll go to B. What is the magnitude of the couple's displacement? Well, displacement is different from the distance. So displacement, we're going to try and find when they start from west and north. We're trying to find the smallest distance, the fastest way to get there, if you were to just take a straight shot. So we want to find this part right here. So we're going to use the Pythagorean theorem, and I know we're going to use this because we have the radius right here, and since we know this radius from this point, we also know that this is the same as this because it's the same radius. It's the circle. So now we have a nice right triangle right here. And this will be our C, and we'll label this A and B. And now we can use the Pythagorean theorem to find the hypotenuse, which will be our displacement. So if we plug in those numbers, we get 1.63 squared plus 1.63 squared, and that will equal C squared. And we get 5.31. But now we have to balance it out because we just want C, so we're going to take the square root of this. And we get 2.31. And that is our displacement, 2.31 kilometers. Now, let's go ahead and do C. What is the direction relative due east of the couple's displacement? So, for this, we're going to want to find this angle right there, okay? Now this will tell us the direction they're traveling with respect to their displacement and with respect to due east. So to find that, we're going to use tangent theta is equal to opposite over adjacent. The reason we're using tangent is because we know these two for sure, and we're going to want to find here, and we're going to want to find C, or we're going to want to find the angle. And it's really easy because we just do theta. To bring tangent over to this side, we do theta is equal to the inverse of tangent times opposite over adjacent. So you could use sine or cosine to try and find this, since we do know C, but for this we're just going to use tangent. And so when you plug everything in, you end up with tangent, the inverse of tangent times 1.63 over 1.63, which is just 1. And that will equal our angle. We should get 45. So theta is equal to 45 degrees, and this is the direction they travel in relative due east. So I hope that helped. If that helped, please like the video so that other students know this is accurate information and that we can help more students with problems like these. So thank you.